Okay, so let's go ahead and jump right into some hypothesis testing. So we are still going to be using just the p-value approach. Again, there is another way that you can do this. I'm not covering that other approach. I'm only going to be covering the p-value approach. If you are interested in the other approach, I am more than happy to go over that on an individual basis. So a reminder about what we want to do in the p-value approach. In the p-value approach, we want to compare the probability of the results from our sample to a level of significance, which is alpha. If the results from our sample, which is our p-value, are less likely than alpha, that's when we reject the null hypothesis. So remember, if p is low, reject HO. So we say that the null hypothesis is false, and the alternative hypothesis is then true. If, however, the p-value is not less than alpha, that's when we would not reject the null hypothesis, and we would say that the alternative hypothesis was not true. So the steps that you can follow as you're going through this, or that I would like you to follow as you go through these, are first, write out your null and alternative hypotheses. Then you're going to calculate the test statistic, which is T naught or TO, and then calculate the p-value for the test statistic. So this is something that you can do steps 2 and 3. I will show you how to do them by hand, and then I will also show you how to do them using the spreadsheet in Excel. Step 4 is to give the conclusion of either rejecting or failing to reject. And recall, we can also phrase failing to reject as do not reject. That's my preferred way of phrasing it, actually. And then interpreting the results. So we're just going to go ahead and jump into an example right now in this same first video. Sorry, I dropped something on my computer. My cat is being bad. So the first example we're going to look at is a bus company has advertised a mean time of 150 minutes for a trip between Denver and Glenwood Springs. A local consumer group had reason to believe that the mean was more than 150 minutes. They sampled 40 trips and found a mean of 153 minutes with a standard deviation of 12.5 minutes. Test the consumer group's hypothesis with a level of significance of 0.05. I'm going to continue what I've been doing by going through and looking at, all right, what did I find in this problem that was significant to me, that I needed? So this bus company is advertising a mean time of 150 minutes. The consumer group believes that the mean is more than what they're claiming. So they took a sample of 40 trips and they found a mean of 153 minutes and a standard deviation of 12.5 minutes. We're going to do a test of their hypothesis with a level of significance of 0.05. So I'll go ahead and take all of the numbers that I underlined, and I'm going to write them off to the side here. 150, this 150, the second one that I underlined is the same as the first. 40, 153, 12.5, 0.05. And then I want to identify what each of these would be. If you aren't sure what the first one is, don't start with the first one. Start with the ones you know. So the level of significance of 0.05, level of significance is always alpha. And I failed to mention this before, but to draw alpha, I always draw like I'm drawing a fish, but then I just don't finish the fish. The standard deviation of 12.5, that's the standard deviation for the 40 samples. The sample of 40 trips, so that's going to be the sample standard deviation. They sampled 40 trips, so that's our sample size. So then I have two means. I have the 150-minute mean that's being advertised and the 153-minute mean that was found from the 40 trips that were sampled. So the 153-minute mean came from the 40 sampled trips. So sampled, so that's going to be the sample mean, which is X bar, which leaves 150 to be mu. And again, mu is typically going to be either prior knowledge, something that's being claimed, historical information. Those are all sorts of things that you would find as mu. So we're going to start now by writing out our null and our alternative hypotheses. If I could spell it right. So null hypothesis starts with HO. Alternative starts with HA or H1. So our null is what the bus company is claiming. So they claim that the mean is equal to 150. And then the alternative is what the consumer group believes. So the consumer group believes that the mean is more than 150. So we have our null and our alternative. So now I'm going to go in and I'm going to calculate my test statistic. So to do this by hand, the formula for the test statistic is T equals X bar minus mu divided by S over the square root of N. So very similar to what the z-score equation for the sampling distribution of the sample mean was, but we don't know what the population standard deviation is. We only know what the sample standard deviation was, so that's why it's a t-score. So I have all of these values off to the side here. I just have to plug them in. So 153 minus 150 divided by 12.5 divided by the square root of 40. So this is 3 over, the bottom is 1.976423538. We want to keep all those decimals until we get our final answer. And now I can round this 1.5179. That is my test statistic, calculated by hand. So then my p-value, I'm going to go ahead and do that by hand. Now, one of the nice things about Excel and the t distribution is there is a built-in right-tailed t distribution function, which is really nice because then you don't have to worry about remembering to do the 1 minus. But you do need to make sure that you identify that because this is greater than, that means this is a right-tailed test. So whenever your alternative hypothesis is greater than, that means you're doing what we call a right-tailed test. And if you think about if we were doing this and we were drawing a curve and labeling the t-score and shading an area, just like we would if this was a z-score, we'd be shading the area to the right because of the keyword more than. And that's what makes it a right-tailed test. So I'm going to go ahead and I'm going to open up Excel. And I have the spreadsheet open, but I'm going to go ahead and open up a new file real quick, a blank workbook. I got a little bit ahead of myself when I was opening stuff up. So the function that we're going to use in Excel is going to be t.dist.rt. So to do this by hand, quote, by hand, it's by hand, but it's using Excel for this part. We're going to do t.dist.rt. I want the right tail. I want everything to the right of the t-score that I'm going to put in. Now, there are two things, I believe two things. It's not telling me, so I hope I remember this. There are two things that I have to enter into this argument for t.dist.rt. The first thing is the t-score, 1.5179. So come up here, 1.5179. The second thing is the degrees of freedom. So degrees of freedom is equal to your sample size minus 1. So our sample size is 40 minus 1. So that means our degrees of freedom is 39. That tells Excel which of those many t-distributions to look at to calculate this distribution, because the t-distribution is slightly different depending on your sample size. So t.dist.rt, 1.5179, comma 39. And we get 0.0686. We don't need a comma true at the end like we do with the normal, because Excel knows that we want the probability of everything above this. We don't want just this probability when we're doing the .rt. So degrees of freedom is what we put in here. And then this guy was our, I'm going to move this over, our t-score. So we found the t-score by hand using the t-score formula. And then we found the p-value. So this guy is our p-value. And remember, the p in p-value means probability. So the answer should be between 0 and 1. When you write the p-value, it should start 0 point something because it's a probability. It is the probability of us observing 153 minutes for the average. So our p-value is 0.0686. So now what I'm going to go ahead and do is I'm going to open up the workbook. I don't need that draft. That's fine. And the third page on the bottom is hypothesis testing for a mean. Make this a little bit bigger. So on the third page, you'll see HOHA, mu equals a number, mu, and then you'll have another drag down where you can pick either less than, greater than, or not equal to. So we want greater than. And then our null is equal to 150. Whoops. And our alternative is equal to 150. And then what is your sample mean? Our sample mean is 153. What is your sample standard deviation? 12.5. What is your sample size? 40. What is your alpha? Again, just like with the proportion one, this alpha is more included in here for people that teach the other method in addition to p-values. Not so much for us, but you can go ahead and put it in there. So our alpha was 0.05. So we can just check and make sure. Our T0, that's our test statistic, 1.5179, and the p-value 0.0686. Those match. They do indeed match. It's not letting me draw. Otherwise, I would draw and circle on it. But it's down here. I can see it. They match with what I found over here. So you can also use Excel. And when you use Excel, you get a T naught of 1.5179 and a p-value of 0.0686. Quick and easy. The only time you have to go through this by hand calculation is if it tells you to do it by hand. Otherwise, you are welcome to use Excel for every single problem. All right, now the only thing we need to do is we need to write our conclusion and our interpretation. And I've hit the bottom of this page. I should have put in a page at the beginning. Oh no, and it's not letting me, oh, because I'm on this page. There we go. So for the conclusion, this is step 4. We're on the conclusion and the interpretation. Remember, for the conclusion, we're going to ask the question, is the p-value less than the level of significance, alpha? Is the p-value too small to be possible? Are the results from our sample too small to be likely? So our p-value was 0.0686. And I want to know, is that smaller than 0.05? My alpha. Alpha is what tells us what is too small. Anything less than 0.05 is what is considered to be too small. So the first digit after the decimal point doesn't tell me anything. Now the second digit, the p-value is a 6. Alpha is a 5, so the p-value is bigger than alpha. So my p-value is not smaller than alpha. So my p-value is not less than alpha, so I do not reject the null. So if I come back up here, I did not have enough evidence to say that this was true. I was trying to prove this. I don't have the evidence I need to prove this, but I can't necessarily say that this is true either. Saying that this is true is like saying that a person is innocent, and we just don't say that. All I can say is that this hypothesis is not true. So my interpretation, I'll write it in green. would say we or there is not or I do not. We do not have enough evidence to support the claim that the mean travel time between Denver and Glenwood Springs is more than 150 minutes. So we did not have the evidence to support the claim that the travel time was more than 150 minutes. And we want to be specific. So there was the travel time between Denver and Glenwood Springs. And that's it. So to recap really quickly, because this was the first one we did, we identified all the important pieces of information. We wrote the null and the alternative hypothesis. We calculated the test statistic. You can do it by hand or you can do it in Excel. We've calculated the p-value. Again, you can do it by hand or in Excel. And then we came to our conclusion that the p-value 0.0686 was not less than 0.05. So that means we do not reject the null hypothesis because p was not low. So do not reject the null. And that means that we do not have the evidence we need to support the claim that the mean travel time is more than 150 minutes between Denver and Glenwood Springs. And that's the first hypothesis test example.